All right, today we're going to talk about something that sounds, kind of technical, but is actually super simple and really useful. It's called mean absolute deviation. If you've ever tried to explain how spread out your data is without making people's eyes glaze over, well, this is for you. Let's dive right in. So let's start with something we can all relate to, waiting for coffee. Imagine you time your wait every morning for a week. You get these numbers: 2 minutes, 5, 3, 8, and 4. Some days are great. One day was a total drag. So how do you describe the typical variation here? That's the question we're going to answer. And to do that, we need to get friendly with this thing called mean absolute deviation, or MAD for short. Seriously, don't let the name throw you. Its real power is just how intuitive it is.
So what is it really? Well, the name kind of gives the whole game away. It's just the average distance. That's it. It's the average distance between every single data point and the center, the mean of all your data. For our coffee example, it's basically asking, typically, how far off is my wait time from the average wait time?
Okay, so why do we care? What makes MAD so useful? Well, first off, it's a breeze to explain. Second, it uses the same units we're already working with, in this case minutes. And here's the big one. It's less sensitive to those crazy outliers, like that one day you waited a ridiculously long time. Other stats can get really thrown off by that, but MAD keeps its cool.
All right, enough theory. Let's get our hands dirty and actually calculate the MAD for our coffee wait times. I promise, it's way easier than it sounds.
It's really just a simple 3-step recipe. First, we'll find the average wait time. Easy enough. Second, we'll see how far each day's wait was from that average. And third, we just average those new numbers, those distances. And that's the whole shebang. Okay, step 1, let's find the mean. We just add up all our wait times. 2 plus 5 plus 3 plus 8 plus 4, that gives us 22. We tracked for 5 days, so we divide by 5. And we get our average wait time, 4.4 minutes. Simple. Now for step 2, finding the deviations. We just look at each day and see how far it was from our 4.4-minute average. So the 2-minute wait, that's 2.4 minutes away. The 5-minute wait, that's only 0.6 minutes away. The key here is we're only looking at the distance. We don't care if it was faster or slower. That's the absolute part of mean absolute deviation. And finally, step 3. We take all those distances we just calculated, the 2.4, the 0.6, and so on, add them all up, and find their average. And there it is. The mean absolute deviation for a coffee wait time is 1.68 minutes. Great, so we have a number, 1.68. But a number by itself is kind of useless, right? What does it actually tell us about our morning coffee routine? Let's figure that out. And this is where it all clicks. That 1.68 means that on any given day, your wait time is typically about 1.68 minutes away from the average of 4.4 minutes. It paints a picture. It tells you that a typical variation is a little under 2 minutes. See? That's a story you can tell someone, not just a random statistic. Now, you might be thinking, wait a minute, I've heard of something like this before, maybe in a stats class? Standard deviation? Yep, they're like statistical cousins. So let's see how they stack up against each other. This table really lays it all out. MAD, as we've seen, is super intuitive. Standard deviation, it's more complex. Why? Because it squares the distances before averaging them. And when you square a number, the bigger numbers get, well, way bigger. This makes standard deviation really sensitive to outliers. So MAD is fantastic for clear communication, while standard deviation is the heavy hitter for deep statistical analysis. So really, it all boils down to your goal. It's a choice. Are you trying to tell a simple, clear, and honest story about your data spread? MAD is your best friend. Are you building a sophisticated statistical model that needs mathematical rigor? Then you're going to need standard deviation. So let's bring it all home. How can you actually put this to use and talk about the spread in your data effectively? Here's your game plan. Use MAD when you need to communicate clearly, especially to people who aren't stats nerds. It's perfect for that. Save standard deviation for your more advanced, heavy-duty statistical work. And you know what? Here's the pro tip. When you're not sure, just report both. Together, they give an even richer picture of what's going on. And that brings us to one last thing to chew on. We live in a world that's just drowning in data and complexity. But sometimes a simple tool like MAD can cut through all that noise and provide some real clarity. So I'll leave you with this question. When is a simple story actually more powerful than a complex one? Thanks for watching.